Hi, you guys. This short lecture is about density, which is a topic I think that you've covered probably in lots of other capacities, lots of other classes. We're not going to do this stuff right here. We'll come back to that. So we're just going down here to physical properties for right now. And be sure to fill in the highlighted areas on your note guide as I go through them. I'm making this one on my iPad, so the highlighted areas are already filled in. So physical properties describe matter. So do chemical properties. That'll be a different lecture, but for right now, just physical properties. Physical properties of matter include things like shape, color, size, mass, volume, density, melting point, boiling point, a few other things as well. Things you can describe physically without, or determine physically without changing the identity of the substance. So you can say what something shape or color is without changing that thing. You could even determine density or mass or volume without changing what it is. Even boiling point and melting point, like if you heat up water so it starts to boil, before it boils, its formula is H2O, and after it's boiled, its formula is still H2O. So you've not really changed it. You've just determined at what point it melts or boils or whatever. So melting point is the temperature at which and pressure at which a solid becomes a liquid. You probably already know these things. Boiling point is the temperature and pressure at which a liquid becomes a gas. Please pause these if you need to fill them in on your note guide. What we're going to focus on today, though, is density. Density is a measurement of how much matter is contained in a certain volume of a substance. Basically, it's defined as a ratio of mass to volume. And it's often measured in either one of these units, grams per centimeters cubed or grams per milliliter. They mean the same thing. So no need to get worked up about what they mean. That's the same thing. The equation for density is D equals M over V, and then density is mass over volume. That's what the D and the M and the V stand for. Sometimes it's helpful to use, and I'm going to draw lots of triangles this year. Sometimes it's helpful to use this density triangle, where you have D equals M over V. And the way the triangle works is you basically put your finger over the one that you don't want to use, and what's left is the equation. So check it out. If I want to solve for density, I put my finger over it, and I'm covering it right now. Use that, get that image in your head, and what's left is mass over volume, right? M on top, V on bottom. And so that is how you determine the equation for density. If you want to determine the equation for, let's say, I want to solve for volume for this problem. And so if I want to solve for volume, I cover that up with my finger, and what's left is volume equals mass over density, right? Mass on top, density on bottom. Finally, if you want to solve for mass, then check it out. Put your finger over it. What's left is density times volume next to each other this time. So mass equals density times volume. It's a quick little trick to rearrange the equation with algebra to help you to solve for the variable that you need. A sample problem is below, pretty straightforward one. It says density. It says if 10 centimeters cubed, I don't know why that's way up there, and I don't know why it's highlighted, of ice has a mass of 9.17 grams. What's the density of ice? Okay, again, these are easy problems to solve because you've been doing this for a while, I think. Whoopsies. And so, the equation is density equals mass over volume. Either memorize it or use the little finger trick I just showed you. And then you plug things in. CM3, that's a volume. Okay, grams, that's a mass. And so when you're doing these problems, those are going to be key things you want to look for. So sometimes CM3 is also milliliters. It means the same thing, but that's still a volume. So when you plug this in, it's not just as simple as taking the first number and putting it on top. Instead, you have to kind of think which one goes where. So in this case, I want the mass on top. So the mass in this problem is 9.17 grams. And then on bottom is the volume of this ice, and it's 10.0 centimeters cubed. You can also write milliliters. It means the exact same thing. And everyone knows that 9.17 divided by 10 is 0.917. What's tricky here is the label. Don't forget the label. Right here you have on top the labels. You can write either one. This one was CM3 right here, and so you might want to put CM3, but you could put grams per milliliter on. Either way, it doesn't matter. So see, it says grams over the milliliters, so your label is grams per milliliter. Very simple. Or grams per centimeter cubed. Each one of those works the exact same way. The chemical properties we'll come back to later, so we're not going to quite do that. But one thing that you should know is that the physical properties are so useful for determining the substance, like what you use to build something. For example, your phone, the physical properties of your phone. Does the certain part conduct electricity? Does a certain part get too hot when it works? Is the screen easy to read? Are the colors bright? These are all physical properties of the materials that make your phone. And so physical properties are often used for substances. Of course, the other property that's not physical or chemical, when they're used to determine, what we should make a phone out of is, what does that material cost, right? Because you don't want to buy a super expensive phone. You want to be able to afford it. Anyway, this is a short lecture on density and how we use it in this class. And it's always been really fun to chat with you. Be nice to each other. Okay, bye.